Now I need to compute the expected value of x times y. So how am I going to do that? The expected value of x times y is going to be a double summation, just like the double integral. A double summation of I multiply j values with the joint probability mass values at I and j values as I changes from 1 to 3 for x random variable, and j changes between 0, 2, and 4 for the second random variable y. So we are basically multiplying I with j and the joint probability mass function here. And let's do that one by one. So let's start with the first probability, joint probability mass value. 1 times 0 times 0.20. It is 0, right? 1 times 2 times 0.20. It is going to be 2 times 0.20. 1 times 4 times 0.10. 4 times 0.10. 2 times 0 will be 0, so I'm not going to do that. 2 times 2 times 0.05. It is 4 times 0.05. 2 times 4 times 0.10 is 8 times 0.10. 3 times 0 will be 0. 3 times 6 times 0.05 will be 6 times 0.05. And finally, 3 times 4 times 0.10. So basically what we are doing is, for all dual combination cases, I multiply the value of the first random variable and the second random variable with the corresponding joint probability mass value and run a double summation over these two sets of values that these random variables can take. And that makes 3.30. Now that the expected value of x times y is 3.30, I'm going to subtract the product of the marginal expectations, and it is going to be 0.15, which is a positive value that indicates that there is a positive dependence relationship between x and y, which means for larger values of x, the second random variable y tends to take large values as well. And for small values of x, the random variable y tends to take smaller values as well. Now, for the second part, we are going to calculate the covariance between 3x and minus 2y. So how I can do that? It is simple, right? Both of these coefficients, 3 and minus 2, can get out of the covariance as a multiplier. So the covariance between 3x and minus 2y is going to be 3 times minus 2 times the covariance of x and y, which is going to be minus 0.90. Actually, I mean, if x and y have a positive dependence relationship, obviously x and minus y will have a negative dependence relationship because it is minus y, okay? So anything that is negative here should be remain as negative coefficient when you take it outside. So because it is going to change the dependence relationship type, right? So this is just a justification for you not to forget.